Okay, here we're given the graphs of two different functions. The curved one is y equals f of x, and the straight one here is y equals g of x. And the first thing we're asked to find is f of 3. So what we need to do, f of 3, well, we know that f of x is shown by the curve. F of 3 then means that we go to 3 here, so we've got an x value of 3. We'll then head up to the curve, and we can see that f of 3 is going to be 12. Next question says, solve f of x is equal to g of x. Now, this is the graph of y equals g of x, this is the graph of y equals f of x, and where f of x is equal to g of x, that's just going to be the point of intersection of the two curves. So that's going to be here, here, and here, and all I actually need to do is write down the x values at those 2 points. So we have 3 different values. X is approximately equal to this one, which is 0.2, and also this one, which is 3.6, and then the last one, which is this one here. Well, you could use 6.1 or 6.2. It's sort of somewhere in between. So I'll put 6.2. They'll allow you a little bit of room for error. Now, fg of 1, what we have to remember here is when we're finding fg of 1, that means that we first of all find g of 1. So that's the first thing that we do, is find g of 1. So I'm going to find this first. Now, in order to find g of 1, there's 1. G of 1 is actually, this is the curve here. Oh, sorry, g of 1 is the straight one. G of 1 is actually going to be here. So g of 1 is actually equal to 5. So this is going to be 5. So what I now need to find is f of 5. So I need to use an x value of 5. Here I can see that f of 5 is actually just 0, because the y value there is going to be 0. So f of 5 is 0. Fg of 1 then is actually just 0. Part D says find an estimate for the gradient of the curve y equals f of x at the point 116. So first of all, let's find the point 116. Well, they've marked it for us here, and we're going to find the gradient of the curve at that point. Now, we don't know the equation of the curve, so we can't use differentiation. What we need to use is draw a tangent to the curve at that point there. And in order to do that, I need to use a ruler. So let's just say about there somewhere. So my tangent is going to be something like that. So there's my tangent to the curve, and my job now is to find the gradient of that tangent. Now, in order to find the gradient, I know that if I've got a sloping line, in order to find the gradient, I need to know this distance, I need to know this distance, in other words, the vertical or the horizontal, or the rise over the tread. So basically, the gradient is going to be this vertical distance, I'll call it v, divided by this horizontal distance, which is h. So let's just do some totting up here. Now, I'm going to draw my triangle, and it helps to make it as big as possible. I'm going to go across like that, and then I'm going to go down like that, and I'm going to work out the distance. So here I'm going from 10, well, that's 20. Every 2 squares is 1. So in other words, it's 10, 11, 12, 13. That's about 14 units vertically. Horizontally, I'm going from, I can see that's 1 unit from there to there, and then each square is worth 0.1. So in other words, it's 1.8 from there to there. So the gradient, now this isn't going to be exact, there's some margin for error here, but my gradient is going to be approximately equal. Let's just check, is the gradient positive or negative? Well, it's positive. The vertical divided by the horizontal, well, that's 14 divided by 0.8, and that's about 100, well, that's 140 divided by 8, which comes out as, I should have done this before, 140 divided by 8 comes out as about 17.5. Oh, rubbish. Sorry, got that wrong. It's not 14 divided by 0.8, it was 14 divided by 1.8. So 140 divided by 18. Now, if you work that out, it comes in around 7.8. So the gradient of that line is approximately 7.8. You would be allowed, I think, anywhere between about 7 and 9. So the gradient, sorry, just going back, my mistake, 14 divided by 1.8, not 0.8, comes out as around 8.